So let's get started into our next event. So what is an SQL? What is an SQL architecture? How does this work? What happens behind the scenes? So when you run an SQL command, you select all from users. You may feel that you get the data instantly when you type the query and send the query, but there is a whole system working under the hood. So let's break down this architecture so that you will understand how these databases are, especially SQL or Oracle or whatever the database may be, it actually process your queries. So what is SQL? It's as we discussed yesterday, it's just a language, but it interacts with this database management system, which has multiple layers of working together. So we have this relational engine, protocol engine, and storage engine. Like on a simple words, it accepts your query and it understands it, it executes it, and it returns the result. So this is how this works. Like the user sends a query and the user will be authorized, and if you have any sensitive data, and then it translate the query conditions and modify the query conditions if necessary, and then it will create a hash value like a binary, like some algorithm, let us say an algorithm or a binary value. That is how computers communicate with each other. So then it will execute the query. So what really happens between these is, so there is this query interface, or we call it as SQL Parser. So this is the entry point. This is the entry point where we get all this information, right? So where we get all these information, like, so let us say you type something like select all from employees where the department in sales. So it first go through this query processor, and this part checks if your syntax is correct or not, and then it breaks the SQL query into a number of tokens. So based on these tokens, it converts into a structured called a parsing tree. So a parsing tree. So what this parsing tree does? So it usually checks your query, and it is how the database management system understand your input. And then this query optimizer, the query optimizer, once this SQL parser completes its work, it goes to the query optimizer. It's a very important layer. Its job, the main purpose of this query optimizer is to get the fastest and efficient way to execute your query. For example, if you have your employee table for more than a million rows, the optimizer will choose the best index. So since we filter with department sales, so that department column might have an index, and it avoids scanning the 1 million rows, and it scans only that particular sales department, and it will reorder the joins and filters to get the details very faster. Even if two people write different SQL queries, the optimizer, this optimizer might generate the same execution plans. The intent is the same. Like let us say you want this department sales, and another person is also on department sales, but he want a particular column and you want another particular column. So the intent might be the same, it is almost the same, right? So that is how this query optimizer works. So then what is this query executor? So now the query is ready to run this execution engine. So whatever we call it here as execution engine. So this execution engine, it takes the optimized plan and starts interacting with the storage engine, right? So it will interact with storage engine and transaction manager, and there will be a buffer manager. So these are the different parts that we have in the in this architecture. So it fetches the data from the disk or from the memory. If it is in memory, it takes from the memory, and it applies all the conditions, and it performs and returns the result. So this is where the real work happens. Everything happens in the execution engine. So in the latest technologies like Spark, distributed computing, we have these execution engines, multiple execution engines. So mostly in traditional SQL, we have only single execution engine, which is powerful enough to get all our data, right? So then what is the next part? It's the storage engine. So this storage engine, it manages how the data is physically stored and retrieved from this disk or memory. So it handles the tables, the indexes, the files that we have over here. It it also, you have to remember that it also tracks where each row lives. Based on that, it will extract those data. So what is the use of this? So most popular systems like this MySQL or other databases, we have different types of storage engines like NoDB, MyESAM. Like these are some of the examples which you don't need to know right away. So you can know these things at a later point of time. But based on our needs, you can choose this. Okay, so then the final portion. What is transaction manager and a buffer manager? So this transaction manager ensures that your queries follow the ACID properties. We'll be doing a separate video on this ACID properties. It's a big topic. All these SQL databases, these follow this ACID transactions. So your data stay consistent even if you have an error, so you don't lose your data anytime. So, and what is this buffer manager? This buffer manager reduces disk rates by catching the data frequently accessed. So what does this mean? So let us say you are acquiring the employees table multiple times. Instead of going every time into the storage and grab the data, it stores the same data in the memory, which we say as caching. So this buffer manager is responsible for that. This makes these SQL databases both reliable and efficient. So let's get into this. It's very simple. So you type your query, it go to the parser, it go to the optimizer, it go to the executor, and then storage engine, and then to data, and finally it gives the result back to you. So how these layers are designed? So each layer is designed to make sure your query is valid, efficient, safe, and fast. This is how your query runs behind your thing. So what are the latest how the latest things work? So in the latest databases, which we called as distributed databases, each data is distributed across a different node. So when we query, your query will be break down into some parts. Example, the Synapse Analytics, your query will be break down into 60 equal parts. Each part will be responsible for gathering information, like that. Right. So this is how the SQL architecture works.